Let me first introduce our office here in Rotterdam, in the Netherlands, briefly, because most of it can be found on the internet, and hopefully you know it already. Founded in 1993 by three people: Winnie Maas, Jacob van Rijs, and Nathalie de Vries. Here in front of the depot here in Rotterdam, one of our latest buildings, together with the partners of the office. Our head office is also in Rotterdam. It's a colorful mixture of people and spaces. We have also our sister offices in Shanghai, in Berlin, and in Paris. But our work is all over the world. So we range from North America to South America to Asia and Australia. And we do this with a happy bunch of 250 peoples from plus 40 nationalities. And that is, for us, it's a very nice environment to work in, with all these kind of different inputs from all over the world. All these people work on different scopes within the office. We do architecture, we do urbanism, housing, leisure, mixed use, culture, public. We have a separate department working on the future of MVRDV and sustainability. We call that MVRDV Next. We also do transformations and interiors. Today I would like to dive into the topic of sustainability and steel constructions, related to one of the buildings I made in Amsterdam, Matrix 1. Before we go into this, into the details of this building, I would like to tell a little bit about what we do in terms of sustainability when we start a project. Not so very long ago, let's say last week, we launched a new part of our website, which is carbonspace.earth, and that's actually free to use for everybody. So it's an open tool in which you can calculate on the basis of a database the carbon costs of your, let's say, concept design. We think this is very important because, as everybody knows, a large portion of the worldwide greenhouse gases is being emitted by our building industry and the things that we build. And these carbon industry, most of the parts will come from the structure, and therefore also the steel structure or the concrete structure. So that's a very important decision to make. And if we split that further up, then the floors and the columns and the basement is a very big portion of that. We made this carbon tool to figure out in a very early stage of our massings that we make on what is actually the impact on our designs when it comes to carbon, our carbon footprint. And we concluded one of the first things is that a rough calculation is already good enough. So on the basis of a simple massing at the beginning of your design, you can already make quite a good impression on how large your carbon footprint is. If we compare, for instance, our valley design here on the right in Amsterdam, as it has been built with a rough model that we use in the early stages, then the difference is more or less 3%, which is not bad. And what is also nice is that we can also already predict the impact of the facade material in this, which is also not that large. So we are quite relaxed when it comes to picking our facade materials. What we try to do is in these early stages of the design is try to optimize the massing in that kind of way that we reach a lower carbon footprint. And in this new plugin or a program that we launched last week, we can compare our MVRDV projects together amongst each other, but you could also start your own project and compare it with projects that we built. So you can challenge yourself to make a more sustainable building than we are doing. And I think especially for students and other architecture offices, this is a very interesting tool. And as said, it's free to use. For our building that we're going to discuss today, I also placed it in our system, our Matrix 1 building. And you see it's, in terms of materiality, it's not the most sustainable building you could figure out. And it has to do with, of course, steel and concrete. So for Matrix, we had to define a different sustainability strategy, because the client wanted really a sustainable building, but he also wanted to make it out of steel and with concrete floors. So that gave us a bit of a challenge. So let me show you how we solve this building. This is the end result, or at least it's the rendering that we made at that moment from the end result, the front and the back side. And the program is offices, laboratories, event and gathering spaces, and some common areas. It's more or less 13,000 square meters big. And we started in 2018 with the design of this building, and we built it in 2020 until 2023. It's located in Amsterdam, the capital of our tiny nation. And I am now at the Blue Spot in Rotterdam, not far away. In Amsterdam, it's located in a campus, in a business park, together with the University of Amsterdam. It's called the Matrix Innovation Center officially. And it has to do because it's part of a campus of more than one Matrix building. So ours is now at the location of this one, but there are actually also 2, 3, 4, 5, and 6. Together with the University of Amsterdam, the idea of the client is that this is a hub for innovation, which means that the students from the University of Amsterdam, as soon as they start their startups, they could rent one of the spaces in these tiny office buildings and do their experiments in the laboratories. And that concept worked actually quite well, but the campus doesn't look so good. It has a lot of office buildings which are very introvert. Let's say there's not much transparency on what's going on inside. It doesn't have much character. And all the social spaces in this campus, which are very important, are either very hidden in the landscape or in the urban setting, or very hidden in the building itself. So there's not much to see from the outside of what's going on inside this building on a social level. The nice thing of a campus, I think of every campus, is that the connectivity between the buildings by walking and by bicycle riding is quite good. There's a huge extent of paths and nice paths through the green to connect all these buildings. And our idea for our Matrix building was, what if we can make this infrastructure, these connections, more social? If you look at the immediate surroundings of our Matrix building, here you can see it in the middle of the image. And then the connections to the outside world are vastly there. Either bike rides, train is there, car is there, bicycle path, footpath, everything is almost there. And our idea was, how can we extend these paths into the building that we have and make this connection more visible? And even how can we go through the building and make the connection to the bicycle path as well? In the end, we did it with a stairs going up into this building. We call that the social stair, which connects the entrance on one facade, and on the back facade you will connect the bicycle entrance, and you will see in the facade these social spaces like the auditorium or the flexible working space. So that's a bit what you see in this facade happening. I think 80% of this building is more or less a functional and very efficient grid size, but through this, more or less 20% is reserved for fun and social spaces. Explaining the social stair, here you can see one of the earlier renderings that we made. It connects the main entrance together with the stairs going up into an education and presentation area. Further upwards to all the coffee and gathering spaces that we normally have when doing a office building, to a little bit of flexible workspaces as well, and a what we call a green lung in this building, some green planting into the walls as well, all the way up to a sky bar, which is very nice for your Friday afternoon drinks. This whole system is ventilated on itself, on a natural ventilation going through the roof at the top and coming in at the bottom via a adiabatic cooling. This is a cooling where you add some moisture to the air to cool your ventilation air. And all this interior is made with sustainable and recycled products. For instance, all the felt that you see on the walls and on the ceiling is made out of recycled bottles, and the furniture as well. Some impressions from the actual result, some pictures. So here you can see the green lung on the walls, and the lighting scheme was specifically designed for this area. Here you can see at the bottom this, the space works very well as a lecture space, or a little bit of an introduction space to the building or the research that has been happening there. And if you go further up, here you can see the flexible work spots and the coffee area. And if you go up even more, then it ends into the sky bar with the openable roof. In the middle of the building is an atrium, and all the offices and laboratories are grouped around them. The route going from the main entrance to the bicycle entrance will go through this atrium as well. And the restaurant on ground floor is connected to this atrium. The restaurant is quite popular with students. I think it has to do with the price of the meals, which is very student friendly, but also it's a very interesting space to be in. Bicycle riding, of course, in Holland, very popular and very much needed in every building. We love our bicycles. So in Holland, we deserve a special entrance for that. And we also try to make this visible in the building itself. So it also stimulates a lot of students to actually use their bicycles. The sustainability story of this building is that we wanted to use steel and concrete, but to make it more sustainable, we wanted to make it demountable and prefabricated. So the elements of sustainability that we used in Matrix 1 can be summed up as the bigger ones: the social, the energy, and the circular. And amongst these typologies or these topics, we made it very specific for our building, where we, today I would like to dive into this demountable structure, the flexible spaces, and especially the modular building system. But all the other topics are also present in this building. Connectivity, I already explained a bit. The social sustainability is very important for the client. For him, it was part of his business case why this campus would work. So he was really supportive on introducing all these social spaces as well, which helps a lot, of course, if your client is also on board with your ambitions. As said, we would like to make it very flexible in its functions. The client as well, they would like to interchange offices for laboratories in the future, depending on the need of the students and the companies that would occupy this building. They wanted to build it fast and modular. So we made it a very modular and prefabricated building. And to do so, we also made it largest and demountable. The parts we cannot demount are underground foundation. It's still not possible to make that in a prefabricated way and in a demountable kind of way. And it has to do with the bad soil of Amsterdam as well. It's basically building a boat on water. And yeah, for that we needed a concrete substructure. Coming to modularity, prefabrication, and demountability, it has to do with each other. Not only, you can only start to prefabricate if you think in modules, and as soon as you have a prefabricated system, the step towards a demountable prefabricated system is very tiny. So we started with the modules. There, of course, the functions are important. As said, we have the offices and laboratories around the atrium, mixed in with the social spaces, the stairs going up. And as said, the offices and the laboratories should be interchangeable. A laboratory looks like this. This is the type that they wanted. It was already set from the start. Because it comes with a certain furniture, a very big laboratory table and some special closet for chemicals and air extraction. And the basis of this laboratory defined the grid of the building and defined as well the office spaces of the building. Here you can see what's happening in floor plan. Basically, it's a double loaded corridor, as we call it, with on both sides spaces like the offices and the laboratories. And through this system goes this social stair upwards. In the corridors, you will find the main distribution of installations. Here you can see that. So this is a section over one floor. Installations is a thing in a laboratory building because there's, I think, 50% extra air extraction needed for such a space. So that was, it needed quite some space. We made it all visible in the corridor, so we have visible installations. This was not possible in the laboratory itself. There, of course, the hygiene control is a bit larger and higher. So there we had suspended ceilings, and the whole interior is made out of prefabricated system elements, which is not very new or spectacular, but the client thought it was very important for its future flexibility. Here you can see a part of the installations. Also, these were prefabricated. It was actually the first time that I did this, and it was very nice to see. So based on the grid of 3 meters 60 of one office space or laboratory space, also the segments for the installations were prefabricated and then hung on site in the empty casco, which you can see here. So it was first the building of the casco and the construction, and then afterwards the prefabricated installations and also the prefabricated wall elements and ceiling elements came in. And this can be changed then in the future by the client. I think he stored some additional doors and windows and interior walls in the attic of the building to be able to change his floor plans in the future as well. With regards to the facade, also there we try to make it demountable, which actually we achieved by leaving out the substructure. Financially, that was also an interesting choice. And the facade is made out of aluminum elements, which are placed on the facade like fish scales. So interlocking, overlapping to keep the rainwater out. Here you can see one of the first mock-ups that we made ourselves. I made the first one in paper. The contractor made this first little mock-up in aluminum scrap material that he had lying around. And as you can see, we made the comments on the mock-up, which seams were good, which ones were not. And this is a bit the way such a process goes on site. Here you can see it more close up, what we commented on. And in the end, he made a full facade mock-up of one of these prefabricated elements, 3 meters 60 wide, 1 floor high, to have it evaluated by us and the city council. Here you can see the end result. So you have these 3-dimensionally shaped aluminum cassettes, which were screwed on the facade directly. And here you can see a bit of the prefabrication of the steel construction. As you can see, the whole construction is bolted, combined with prefabricated concrete slabs, which can be used in theory afterwards as well when you start demounting the building. And we actually have examples in the Netherlands of new buildings which are being built of wasted elements from other buildings. That has some downsides, of course. You can't weld in such a demountable construction, so everything is bolted. And somebody had the lucky job of painting all these bolts with a black color after it was finished. We'll go a bit through the construction, and you can see the concrete base. So that is the concrete part of it, which is on site and is not demountable. But on top of that, the whole steel construction was built with the stair construction in it, and per floor the concrete slabs were mounted on it. After that, you see the prefabricated elements for the facade coming in, and the fish scales of the aluminum elements were screwed afterwards on it. Otherwise you would see all the seams, and we do not like that in general on our buildings. And this is then the end result with a picture when it's occupied. In this project, we also made a material passport. That's a system here in the Netherlands, and I think it's also now in Germany, Denmark, and Norway, where all the building elements are collected. It's an interesting thought with the idea on how can we prevent buildings becoming waste in the future. So as soon as you start emitting or having a carbon footprint for your building, of course it's not very good, but it would even be worse if it becomes waste in the future. So can we demount our building, and can we prevent our building to become waste? Behind that, there's a theory that all the elements in a building that you use have a certain lifespan, and of course it's good if you can recycle or reuse the stuff which is in the building, which has the shortest lifespan as much as possible, going up to the elements that last much longer. What we did in Matrix is we made our 3D Revit model, our BIM model, in that way that we could upload it to this material passport, and all the information that we have about our building will be saved for the future. So in the future, if somebody needs to have building materials, he knows where he can find it in our building if it's being demolished. Here you can see our Revit model that we made at that time, and we made the inventory of all the elements which are in our building. And that's it. So also this model was being used by the client as well for its maintenance. So all the information regarding the building, for instance, the interior elements, how many do they have there, the glass types, everything is stored inside this 3D model. So also in terms of maintenance, the client can access it and hopefully updates it as well. And that was the presentation of Matrix 1.